Hello, everyone. My name is April Locklear, and today I'll be talking about GenX contamination, a growing concern for both human health and the environment, especially right here in North Carolina, where I'm from. My presentation will explore what GenX is, why it's considered a forever chemical, and how scientists are studying it. Also, what steps are being taken to protect our water and communities. GenX is a man-made chemical that belongs to a larger family known as PFAS, or polyfluoroalkyl substances. It was introduced as a replacement for PFOA, the chemical once used to make Teflon nonstick coatings. Unfortunately, GenX shares many of the same problems. It doesn't break down naturally, earning the nickname Forever Chemical. These chemicals are found in everyday products like waterproof clothing, nonstick cookware, and even food packaging. Gen X is a serious threat because it lingers in our soil, air, and water for decades. Studies have linked it to liver damage, immune system issues, and possibly cancer. One of the most concerning factors is bioaccumulation. Once it enters plants, animals, and humans, it builds up over time rather than being flushed out. That means even low levels can become harmful after long exposure. Here in North Carolina, the Cape Fear River has been the focus of major concern. Since the 1980s, the Comores plant near Fayetteville has released GenX into the environment. This river provides drinking water for over 250,000 residents downstream. Researchers from NC State, the EPA, and the North Carolina Department of Environmental Quality have been investigating the contamination and its long-term effects. For many residents, this isn't a distant issue. It's something that directly affects their health and daily life. To understand how genetics spreads and impacts health, scientists use several advanced methods. They collect water samples and measure contamination at parts per trillion, an extremely tiny amount. They use tools like mass spectrometry and chromatography to detect and analyze these compounds. In the lab, toxicologists study how genetic affects animal organs and development. Hydrologists also use models to track how the chemical moves through groundwater and rivers, helping predict where contamination might spread next. Through years of research, scientists have found GenX not only in water but also in rain, fish, and even human blood samples. Traditional water treatment systems cannot fully remove it, which makes it an ongoing public health issue. Some studies have shown signs of liver and developmental toxicity in animals, and while more research is needed, the potential risks for humans are taken very seriously. Thankfully, there are promising steps being taken. Technologies like granular activated carbon and reverse osmosis are proving effective at filtering out PFAS, including GenX. Regulatory agencies like the EPA and North Carolina DEQ are tightening discharge limits, requiring cleanup efforts, and promoting safer manufacturing processes. Researchers are also working to design alternative chemicals that break down naturally and don't persist in the environment. In 2024, the EPA introduced strict national standards for PFAS levels in drinking water, as low as 4 parts per trillion. Comores is now legally required to reduce emissions and clean up contaminated sites. Still, cleanup is extremely costly, and we do not yet know all the long term health effects. Many communities are still dealing with contaminated wells, and it may take decades to fully remove these chemicals from the environment. In conclusion, Gen X represents one of the most complex environmental challenges of our time, but it also shows the importance of science, regulation, and public awareness working together. Every step taken, from research to policy to personal action, moves us closer to cleaner, safer water for everyone. Thank you for listening.